Hello, and welcome to a video about domain and range. First, let's write down some definitions. Domain is the set of all independent... Oh, that's too thick of a pencil. Give me a sec. There we go. Of all independent values. These are your x values. You know what else we call the independent values that you can think of, which is, I think, very useful for domain and just evaluating? Input. Range is the set of all dependent values, which you can also call the output. These are our y values. So we put the x into the equation and we get a y out. So domain is plugged in, the x's, the range is what we get out, the y's. Let's identify the domain and range for a couple of relations. Now, you don't have to necessarily have a function to have domain and range. It just has to be a relation. For tables, this is how we're going to write domain and range. Well, for domain, I'm going to start with the letter D. The domain is the set of all x's. So, all of these numbers. One thing we have to do is organize them from smallest to largest, and we have to use squiggly brackets and commas. So, let's just label this as the domain. So I'm going to do a squiggly bracket and put these numbers in order. 0, 2, 4, 6, 8. For the range, I have my sets of y's. Now here you have f of x. Remember in our previous lesson, we talked about how f of x is actually the same as y. We'll do the same. They're organized already, so let's just rewrite them. 4, 5, 6, 7, 8, and end with a squiggly bracket. Let's do that again for number 10. All right, domain, those are our x's. Now, you should notice that in this domain, I have two 1s. We only need to write that one once. So I'm going to write it 0, 1, 2, 4. Same thing goes with range. If anything repeats, I still only write it once. Alrighty. Let's take a look at 11. Okay, here we have a set of ordered pairs, and we still need to look at the x's and y's, the domain and range. I'm going to color code it because that makes it a lot easier for me, honestly. So I'm going to highlight my domain, my x's first. And it looks like they're already in order, so I'll just rewrite them with commas in between. Perfect. Let's do the same thing for our range. I can see them quite well without having to highlight them at this point, but I'm committed to the color coding, so here we go. All right, in order from smallest to largest, I've got -2, 0, 1, 4, and 9. Number 12, we're going to use this graph to identify domain and range. Domain is our x's from smallest to largest. On the graph, that means we're looking from left to right. Let's write that down. We go, I think the preset on these is too thick. I don't like it. There we go. This will be our left, our smallest side, and this will be the right, our largest side. Let's take a look at the graph. Okay. On the left, our graph ends right here. This is the furthest left it goes. On the right, it's right there. This is the furthest right it goes. So it looks like we go from -1 all the way to 4. We also use some inequality symbols here, so let's write them in. we're going to use this less than or equal to because x is in between -1 and 4. So if you kind of look at it on this side here, x is greater than or equal to -1, so that's bigger than -1. It's also less than or equal to 4, so it's smaller than 4, making x appear in between -1 and 4. Let's do the same thing with our range. Range now are our y's. Our y's go up and down, so we're going to go from bottom to top. Let's write that down here. All right, I forgot. I need to make this a thinner pen. All right, so we're going to go from bottom to the top. Let's check it out. All right. The bottom of my graph is right here. And that is at -2. I'm going to write that down right away. -2. The top of my graph is right here. And that's at 3. And I'm going to put my inequality symbols. Same as before, y is in between -2 and 3. Now something to keep in mind, it's not always going to be all the way to the left side and all the way to the right side of the graph. I'm basing my left, right, top, and bottom based on that bold line. I wish I could point at it to you right now. Let me draw over it. I'm just going to highlight it so you see. I'm talking about the left, right, bottom, and top of that line in particular. It just so happens to go all the way left, all the way right, all the way to the top and bottom of our graph. We will do examples together later in class and during classwork where that won't happen, so you'll get to see that. Okay, now what we're also going to do with this graph is talk about the increasing, decreasing, and constant intervals. Increasing means our graph is going up. Decreasing is down, constant is flat. Now, the way it will look, I know I just drew the arrows, and I want to redraw them. Increasing would be going up and to the right. Decreasing is going to be going down and to the right. We always go left to right. You'll see that a lot in mathematics. We're looking at things left to right, just like we read in English, so that's very useful. Let's take a look at our graph. I see 3 intervals, meaning 3 times where we change direction. And this is what I mean. I'm starting on the very left, and if I go from left to right, it looks like my pen is going down. So it's decreasing. Then it looks like my pen is going flat for a while. That's constant. And then looks like I'm decreasing once more. We're going to write down those intervals. We are always focused on the x's. It is all about the domain here. Because the domain is our input, it's the independent value. That's why we're so focused on it. Because we don't need to really know about the range, the y's, the dependent value when we don't know, if we don't know about the independent. So we are first decreasing, which I highlighted in pink, from -1. I'm going to use those same inequality symbols to mean in between. And it goes all the way to right here, which is at +1. Then I'm constant. It looks like I start being constant at 1, exactly where I stopped decreasing. And then I stop being constant at 3. Then I have one more interval of decreasing. I'm just going to put a comma next to D for decreasing, or you can add another section down here, however you feel. I'm decreasing from 3, where I finished being constant, all the way to the end of the graph, which is at 4. There it is. Let's do that one more time. Number 13. Let's do the domain and range, and here you see it's not going all the way left to right, top to bottom, just like I said in number 12. All right, let's do it. So we're going left to right for our range, bottom to top for our, did I say range? I feel like I misspoke, so I'm going to say it again. We're going left to right for domain, bottom to top for range. All right, let's do it. Left. This is the leftmost part of our graph, and that's -7. The rightmost is right here, and that's at +6. Now let's do bottom to top. The bottommost part of our graph is right here. It's at -2. That's where that line, that's the lowest that line goes. And the tallest part of our line is right here at 8. There's our domain and range. Next, let's talk about increasing, decreasing, and constant. All right, let's see what our first interval is. First, from left to right, I'm going flat. That's constant. Then it looks like I'm going up. That's increasing. And then it looks like I'm going down. Oh, those colors are too similar. I'm going to use purple. Then it looks like I'm going down for decreasing. Let's write the intervals down. It really doesn't matter what you write down first. I like to just go in order left to right. So since we have constant first, I'm going to write constant first. Okay. We start at -7. Remember, it's all about the x's. And we stop being constant at -4. Next, I'm increasing. I start from that -4 where we finished being constant. And we go all the way to 1. And then it looks like we're decreasing for our final interval. At the 1 where we stopped increasing. And we end at 6 where the graph ends. Let's do it one more time. I didn't label this, or I didn't label this. I didn't find a graph that was labeled, so it's very safe to assume that it goes by ones. So every square is 1. On that note, left to right, bottom to the top. All right, let's see what we got. I'm going to write in my inequality symbols right away. Why? I don't know. I just feel like it. Let's zoom in a bit. Beep, 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 beep. Okay. Oh, what did I mess up here? Oh no. Oh no. Okay. Let's start on the left. This is the leftmost part of our graph, and that's 1, 2, 3, 4. That's -4. Okay. The rightmost part is here, so that's 1, 2, 3, 4, 5, 6. Okay. The bottom of my graph is here. That's 1, 2, so that's -2. And then the top is right there. 1, 2, 3, 4. 4. All right. Let's do increasing, decreasing, constant. All right, left to right. As I start on the left and go to the right, it looks like first I'm decreasing. Then I begin increasing. And then I'm decreasing again. So there's no constant intervals. Oh well, let's write them down. So first we're decreasing. Remember, this is all about the x's. So this is -4. So we start at -4, and we're decreasing all the way to, oh, yeah, it's -3 right there. Right? Yeah, right there, that's -3. Okay. Then it looks like we're increasing. Start at that -3 where we finished decreasing. And we're going all the way up to here, which is 1, 2, 3. And then the last interval, we're decreasing again. We start at 3 where we finished increasing. And we go all the way up to 6 where the graph ends. All right. That's it for Unit 1. I know domain and range is tough to see sometimes. We will be practicing it. If you have any questions, make sure to ask me or whoever else is helping you out with math. Otherwise, have a wonderful rest of whatever day it is for you. Bye!